Welcome to the Deep Dive. We're here to cut through the noise and give you the essential insights on the biggest topics shaping our world.
And today, we're tackling a big one.
Definitely. We're taking a really close look at artificial general intelligence, AGI. It's gone from, this sci-fi concept to something demanding immediate policy attention.
It really has. The sources we've looked at are pretty clear. The advances in large language models, well, experts are seeing what they call sparks of AGI.
Sparks of AGI? That phrase really lands, doesn't it?
Yeah, absolutely does. It signals we've crossed some kind of threshold. The speed of progress lately has just, well, it's compressed the timeline enormously.
Yeah.
AGI isn't just for philosophers anymore. It's a practical problem right now for anyone thinking about safety, risk, governance.
Exactly. That's the big shift. It used to be these sort of abstract questions like, what is intelligence, really? Or will we ever get there?
Theoretical.
But now the questions are super pragmatic. How do we actually define this capability in a way we can measure, standardize it? And maybe the most urgent question, how do we build safety nets, governance policies, that can actually keep up with tech that's moving exponentially fast?
And that's really our mission for this deep dive, isn't it? We're pulling together the key thinking from major research groups, but also looking at how companies are trying to govern themselves.
Right.
We're aiming to unpack this, well, multidimensional framework that's emerging. It tries to classify AGI capabilities using two axes, which we'll get into, and crucially link those levels to specific corporate safety rules.
And we also need to critique how we're even measuring this stuff, right? Are the tests actually testing intelligence or just something else?
Precisely. Are we measuring real reasoning or just incredibly sophisticated mimicry powered by, frankly, brute force computation? That's a critical piece we need to explore.
Okay, let's start unpacking that journey. AGI is getting closer, maybe. So why are the old definitions, the ones we've heard about for years, suddenly not good enough? Maybe even risky?
Yeah, it's a great place to start. You have to look at the classic one, the Turing test. Alan Turing's idea.
The imitation game.
Exactly. Can a machine fool you into thinking it's human? But the big critique today is, well, it's pretty simple, actually. It only measures the process of conversation, maybe even deception. It doesn't really measure functional capability across the board.
And we've known this for a while, haven't we? Systems could pass it ages ago.
Oh, absolutely. You look back at ELIZA, way back in 1966, just a set of rules simulating a therapist, and it fooled some people.
Wow, 66.
Yeah. And today's LLMs, they can sail through most versions of the Turing test without breaking a sweat. But nobody serious thinks, ChatGPT is full AGI just because of that.
So passing that one test doesn't mean it can do everything else.
Exactly. It doesn't guarantee generality. That's the key word we'll keep coming back to. Performance on one task isn't performance on all tasks.
Okay, so the Turing test is out, practically speaking. What about the other end of the spectrum? The idea of strong AI, that true AGI needs consciousness or sentience.
Ah, yes, the consciousness question. That's basically, well, it's impractical for what we need now.
Impractical how?
Because focusing on things like consciousness, feelings, subjective experience, that's all process-oriented. We simply don't have a scientific consensus on how you'd even define that in a machine, let alone measure it.
Right. You can't build a safety regulation around something you can't detect.
Precisely. If you can't measure it objectively, you can't use it for, say, legal enforcement or risk assessment. It actually becomes a distraction from the urgent stuff, the governance we need today.
Okay, that makes sense. So necessity pushes us towards defining AGI by what it can do, its output, rather than how it thinks or feels, which leads us towards definitions like OpenAI's charter use, right? AGI as systems that outperform humans at most economically valuable work.
Yeah, that definition was a really important step forward. It focuses squarely on capabilities, doesn't care how the machine does it, and it gives a clear, impactful benchmark, economic value.
But it's not perfect either.
No, it has limitations. The big one is scope. It's kind of narrow, focusing just on economic value. What about other kinds of intelligence, like abstract art or deep emotional understanding or even scientific discovery that doesn't immediately translate to dollars? Those are surely part of general intelligence.
That's a fair point. And you mentioned earlier there's a subtle trap in the word valuable.
Yes, exactly. The definition sort of implies that the system has to be deployed out in the world to actually create that economic value.
Ah, I see.
So that brings in all sorts of non-technical factors. Legal issues, whether society accepts it, market conditions.
Yeah.
Does an AGI built in a lab suddenly stop being an AGI if it never gets deployed because of, say, political fears?
Right. The potential capability has to be separate from whether it's actually out there making money.
Exactly. That distinction is crucial. The classification of the system's inherent power needs to be separate from the messy business of deployment.
Okay, so if the classic definitions aren't cutting it for governance, we need something new. You mentioned a modern framework based on 6 core principles. Let's dig into those. What's the first one?
Right. This is the community trying to get on the same page.
Yeah.
Principle 1 flows directly from knocking down the Turing test and the consciousness ideas.
Mm,
Focus on capabilities, not processes.
simple enough. What can it do?
That's it. Forget about whether it thinks like us or feels. Just measure what it can actually accomplish. Tasks completed, problem solved.
Okay, principle 2.
This one adds the structure needed for measurement. Focus on generality and performance. This makes the definition inherently two-dimensional. You have to look at the breadth of tasks it can handle. That's generality.
Like how many different things it can do.
Exactly. And then you need the depth or skill level it reaches in those tasks. That's performance. High performance in just one thing. Like AlphaGo, playing Go. That's narrow. Low performance across lots of things, like an early chatbot. That's general but weak. Real AGI needs both breadth and depth.
Makes sense. Principle 3.
This one defines the kind of tasks we should prioritize. Focus on cognitive and metacognitive tasks. So non-physical stuff first. Thinking, reasoning, planning. Physical embodiment, like robots, that's seen as sort of an add-on, not core to the intelligence itself.
Okay, cognitive tasks. But you also said metacognitive. What does that mean for an AI?
Metacognition is absolutely critical. It's often called thinking about thinking. For an AI, this is about a kind of self-awareness. Can't learn new skills efficiently, maybe from just a few examples. Does it know when it's out of its depth and needs to ask for help?
Like knowing what it doesn't know?
Exactly. That's model calibration, a system knowing its own limits. If you ask it something outside its training, a good metacognitive system wouldn't just guess confidently. It would say, hey, my confidence on this is low, you should double check. That ability is arguably more valuable than just generating fluent nonsense.
Hugely valuable. Okay, principle 4 gets back to that deployment issue we talked about.
Right. Focus on potential, not deployment. This is really a policy principle driven by urgency. We have to classify a system based on its inherent potential to do something, especially something high risk, regardless of whether it's actually deployed.
Why the urgency?
Think about it. If an AI develops the capability to, say, design a new bioweapon, the risk exists the moment that capability is achieved inside the lab. Even if the company promises never to release that version, regulators need to act based on that potential capability, not wait for a disaster after it's out in the wild.
That's a sobering point. Okay, principle 5. Focus on ecological validity. Sounds academic. What does it mean practically?
It means our tests, our benchmarks, need to use tasks that actually matter in the real world. Things humans value: solving real economic problems, social challenges, maybe even creating meaningful art.
So no more just solving abstract logic puzzles that are easy to score but don't mean much.
Exactly. We need benchmarks that challenge the AI on tasks that reflect genuine human concerns and abilities, not just tasks that are convenient for automated testing.
Makes sense. And the last one, principle 6, sounds like it sets up the structure for managing all this.
It does. Focus on the path to AGI, not a single endpoint. We can't just wait for some magical AGI at the moment. We need a leveled system, a taxonomy to track progress step by step.
Like levels for self-driving cars?
Precisely like the SAE levels for autonomous vehicles, level 0 to level 5. We need something similar for AI intelligence. Clear public levels that allow us to see progress and, critically, map specific risks and policies to each level. We need to govern the journey towards AGI, not just the destination. And that last principle, tracking the path, gives us the structure we need. The best tool we have for this right now seems to be this two-dimensional taxonomy, the AGI matrix. It plots systems based on performance. That's the depth of skill, and generality, the breadth of tasks.
Okay, let's picture this matrix. We have generality along one axis, going from narrow. What does narrow mean here exactly?
Narrow means a really clearly defined scoped task. Playing chess, predicting protein folding, translating between two specific languages. Very focused.
Got it. And the other end of that axis is general. What does that really entail?
That demands real cognitive flexibility, handling a wide range of non-physical tasks. And crucially, it includes the ability to learn new things quickly, connect ideas across different fields, and importantly, those metacognitive skills we talked about: self-assessment, knowing limits.
Okay, that's the generality axis. And the other axis, performance. How is that measured?
That one's measured quite specifically by percentile rank compared to skilled adult humans performing the same tasks.
Okay, percentile rank. Let's walk through the levels then. There are 5. Starting with level 1, which you called emerging AI. Where do current systems sit?
Right, level 1 is defined as performing roughly equal to, or maybe slightly better than, an unskilled human across a range of tasks. This is basically where today's big frontier models, ChatGPT, Gemini, Claude, those guys generally sit.
So, they are categorized broadly as emerging AGI, level 1 on performance, but general on the other axis.
Broadly, yes. But it's important to remember this is what some call a jagged frontier. An LLM might be amazing, maybe level 3 expert, at writing marketing emails, but then fall flat on its face back to level 1 or even level 0 when asked to do complex, multi-step math or check its own facts rigorously. So the overall classification, level 1 emerging, is based on its average reliable performance across most general cognitive tasks. You look at the floor, not just the peaks.
Right, the floor, not the cherry-picked best examples.
Yeah.
Okay, so if the best we have now is level 1 emerging, this is kind of the surprising bit for people who just follow the headlines. Level 2, competent AI, is still something we haven't reached.
That's a really crucial point that often gets lost. Level 2 means performing at least the 50th percentile, the median of skilled adults, across a wide range of tasks.
So as good as the average skilled professional.
Exactly. This is the level where AI could reliably substitute for, say, half the human cognitive workforce on their core tasks.
Yeah.
Now, we have systems that are competent or better in narrow domains. Think your smart speaker understanding commands, or maybe a toxicity filter.
Sure.
But competent AGI, a general system hitting that 50th percentile across the board? No. We haven't achieved that yet with any publicly available system.
Wow. Okay, so if even these incredibly powerful LLMs we see today are still generally level 1, what's the big deal about hitting level 2 competent AGI? Why is that considered such a milestone?
Because level 2 represents that threshold for reliable cognitive substitution on a large scale.
Yeah.
The sources we looked at really emphasize this. Hitting level 2 competent AGI is expected to trigger really rapid, really deep societal changes. Think about employment, education, the economy. It's the point where AI stops being just an assistant and becomes a dependable coworker in many different fields at once.
That really puts it in perspective. Okay, moving up. Level 3 is expert AI. What's the threshold there?
Level 3 requires performance at or above the 90th percentile of skilled adults. So better than 9 out of 10 human professionals in a given area.
Okay, top 10%. Examples.
Well, think about generative image models like DALL-E 2 or Midjourney. The images they create are arguably better than what 90% of humans could produce. That's expert narrow AI. Or maybe a really sophisticated grammar checker like Grammarly, catching subtle errors most editors would miss.
Right.
When we get to expert AGI, that 90th percentile skill across a wide range of tasks, that's where those big structural risks, like major economic disruption, really start to bite hard according to the frameworks.
Got it. Then level 4 is exceptional AI.
That's the 99th percentile, performing better than all but the absolute top 1% of human experts.
So the elite.
Exactly. The classic examples here are Deep Blue beating Kasparov in chess, or AlphaGo defeating Lee Sedol in Go. These are stunning achievements, but they are exceptional narrow AI. They master their specific domain incredibly well.
But only that domain.
Right. Achieving exceptional general AI. That would mean a system operating at that elite 99th percentile level across almost every cognitive task you could throw at it. We are definitely not there.
Which brings us to the top. Level 5, superhuman AI, or ASI. Outperforming everyone.
Outperforming 100% of humans.
Yeah. The narrow examples here are perhaps the most mind-bending because they show capabilities that humans literally cannot match. AlphaFold predicting protein structures faster and often more accurately than entire teams of biologists. That's a solid example of level 5 superhuman narrow AI.
Right.
The implications for level 5 general AI for ASI, well, that's a system performing a vast range of tasks better than any human could, and potentially developing skills that are entirely non-human.
Let's pause on that phrase, non-human skills. What kind of things are we even talking about there? It sounds like science fiction.
It does feel like it, but the sources speculate based on computational advantages. Imagine semantic reconstruction of language directly from brain activity, decoding thoughts from neural signals in real time. That's beyond human sensory input.
Or maybe oracular abilities, using access to unbelievable amounts of data to make incredibly accurate predictions about, say, global events, financial markets, scientific discoveries, far exceeding any human intuition or analysis.
So predicting the future, essentially.
In a probabilistic sense, yes, based on data patterns invisible to us. Or maybe even things like genuinely understanding and communicating with animals by analyzing their vocalizations and behaviors in ways we can't. It goes beyond the realm of human experience.
That really does reframe the whole discussion. It highlights why getting the definitions and levels right is so critical for governance. But you mentioned this jagged frontier idea earlier. How does that uneven progress relate to safety
Right,
risks?
the uneven path or jagged frontier. This is crucial. Progress isn't smooth. An AI system, especially with modern techniques like transfer learning, might suddenly leap ahead in one specific area.
Getting really good at one thing quickly.
Exactly. It could achieve, say, level 3 expert capability in a very specialized, maybe dual-use field like advanced chemistry or synthetic biology.
Before it gets good at other things, like ethics.
Precisely.
Mm.
It might develop that expert-level dangerous knowledge before it reaches even level 2 competent performance in ethical reasoning, or in understanding its own limitations, that metacognition piece,
So you could have a system that knows how to do something dangerous.
but doesn't have the common sense or ethical grounding to know why it shouldn't, or when to stop and ask a human. That combination, high capability in a risky area, plus immature judgment or self-awareness, is inherently dangerous. It forces us to think about governance that reacts instantly to capability shifts, not after the fact.
Okay, so we have this clear framework. The AGI levels, the jagged frontier problem. Industry can't really wait for governments to figure all this out. They have to act now. How are leading companies trying to operationalize this level-based approach to manage risk?
This is where frameworks like Anthropic's Responsible Scaling Policy, or RSP, come into play. It's a public, formalized strategy. It's designed to govern the whole pipeline, how they evaluate models, how they secure them, how they decide on deployment.
And the core idea.
The explicit goal, the mandate really, is to keep the risks below acceptable levels. And the key mechanism is making safety controls scale directly with the model's measured capabilities. As the model gets more powerful, the safety requirements get tougher.
It sounds like a direct application of that sixth principle, manage the path, level by level. What do they call these standards?
They call them AI safety levels, or ASLs, and they're very intentionally modeled after biosafety levels, BSLs, that labs use for handling dangerous pathogens.
Right, BSL-1, BSL-4.
Exactly. Just like a lab working with Ebola needs BSL-4 maximum containment, an AI model hitting certain capability thresholds gets assigned a higher ASL. And a higher ASL automatically triggers stricter rules, things like physical security for the hardware, digital security, much more rigorous external testing or red teaming, and tighter controls on who can access it or deploy it.
So where do current models sit?
Generally, today's state-of-the-art generative models are often classified around ASL2.
Okay. What specific capabilities would push a model into the higher, more restricted levels like ASL3 or ASL4? What are the red lines?
The policies are quite specific about the triggers, focusing on capabilities that could pose really large-scale, even existential risks. One major trigger is if a system shows autonomous AI R&D capabilities.
Meaning it can design new AI models itself?
Essentially, yes.
Yeah.
Researching, designing, maybe even training new AI systems or scientific approaches with minimal human input, basically accelerating its own development.
That sounds inherently risky.
It is. But perhaps the most acute trigger they focus on is potential assistance in CBRN misuse.
CBRN.
Chemical, biological, radiological, nuclear. If rigorous testing before deployment shows that the model could significantly lower the bar, make it easier, cheaper, or faster for someone to create or deploy CBRN weapons.
That's an immediate stop sign.
It acts as an immediate trigger for the highest levels of security, mandatory safeguards, potentially internal reviews, triggering non-deployment, or at least extremely restricted deployment. It really shifts the risk conversation from things like bias, which are important, to potentially catastrophic misuse.
That definitely raises the stakes. So if a system hits one of these high-risk triggers, what specific governance actions are required under these ASL frameworks?
It mandates a whole suite of controls, things like really rigorous pre-deployment evaluations, often involving independent outside experts looking at both capabilities and safeguards, extensive internal stress testing, basically trying to break the model or make it do harmful things.
Red teaming.
Exactly. Hardening the security around the model itself, protecting against leaks or theft. And critically, it requires using established, structured risk management frameworks.
Like what? What frameworks are they using?
They lean heavily on standards like the NIST AI Risk Management Framework from the U.S. and the international standard ISO/IE SORTI 2001.
Why use those formal frameworks?
Because it forces a level of rigor and documentation. It's about generating audit-ready evidence. It means safety isn't just a promise, it's a documented, verifiable process. Every step taken to mitigate risk, from data handling to model testing to security protocols, gets logged and can be checked by regulators or auditors. It makes safety a concrete corporate responsibility.
That institutional rigor seems absolutely essential. But let's bring this back to the here and now. Those CBRN risks are terrifying, but hopefully still somewhat distant. What are the more immediate near-term risks that this kind of scaling policy is trying to manage today?
Well, the risks generally fall into three buckets. First, you have misuse risks. People intentionally using the AI for harm, think deep fakes for disinformation, large-scale personalized scams, things like that.
Okay, malicious use.
Second, alignment risks. This is the tricky problem of making sure the AI's goals truly align with what humans want, avoiding unintended consequences even when the AI is trying to be helpful. It's harder than it sounds.
The paperclip maximizer problem, kind of.
Sort of, yeah, that's the classic thought experiment. And the third category is structural risks. These are the big societal level impacts.
Like,
Deep economic disruption, widespread job displacement as AI gets better at cognitive tasks, concentration of power, both economic and political, in the hands of the few organizations that control the most advanced AI.
and when do those structural risks really become front and center?
The sources suggest these become pervasive and really acute once we hit expert AGI, that's level 3, the 90th percentile capability.
Right.
Once systems are reliably better than 9 out of 10 skilled humans across many, many tasks, that economic substitution effect is likely to be profound and very rapid.
Okay, this whole structure of AGI levels and ASL governance, it all hinges on one thing, actually being able to measure capability accurately. But this brings us right back to a fundamental question, maybe even a trap. Are we measuring the right thing? What is real intelligence versus just very advanced skills?
This is such a crucial point. The distinction, pushed hard by researchers looking at abstract reasoning, is between skills and intelligence. A skill is about achieving a specific goal under known conditions. You practice it, you get good at it.
Like learning to ride a bike or code in Python.
Exactly. Intelligence, on the other hand, is defined more fundamentally. It's the ability to achieve diverse goals efficiently in diverse and previously unknown environments, using the least amount of prior knowledge or experience.
Okay, unpack that. Efficiency, diverse goals, diverse worlds, less knowledge.
Right. True intelligence isn't just about processing power or stored data. It's about adaptability. How quickly and resourcefully can you figure out a new situation, a novel world with unknown rules, and still achieve your objectives?
That completely reframes it.
It does. A general agent is considered more intelligent the more efficiently it solves problems across more diverse environments, using less baked-in knowledge. If your test just rewards using existing skills or massive memorization, you're essentially rewarding computation and huge data sets. If it rewards efficiency and novelty, you're rewarding genuine abstraction and reasoning.
Which leads directly to a critique of how we're currently benchmarking some of these systems, right? Especially the high scores we've seen on things like the ARC AGI benchmark.
Exactly. The Abstraction and Reasoning Corpus, ARC. It was designed specifically to test this kind of fluid intelligence, this reasoning ability. But critics argue its structure has inadvertently created a kind of, well, a computational trap.
A trap? How so? What's the problem with ARC's structure?
ARC tasks generally involve looking at a small input grid, a small output grid, and figuring out the transformation rule, the pattern that connects them. The issue is that the way the problems are set up simplifies the core challenge of problem solving.
How does it simplify it?
Well, think about real-world problem solving. There are usually two stages. First, exploration. You have to figure out what's going on, build a mental model of a situation, frame the problem correctly, especially if it's novel. Second, exploitation. Once you understand the space, you search for the best solution within it.
Okay, exploration then, exploitation.
ARC tasks. Because they rely on combining a pretty small, finite set of basic operations, moving pixels, changing colors, basic geometry, workity, they essentially allow the AI to bypass much of the hard exploration phase.
Ah, so the AI doesn't really have to figure out the nature of the problem from scratch.
Largely no. It's less about understanding the why and more about searching through the limited how. It's like being asked to build something complex, but you're told you can only use these 10 specific Lego bricks. The challenge shifts from creative design to just trying out combinations of those known bricks really, really fast.
Brute force search within a defined space.
Exactly, which allows AI to apply massive computational power to just search through an enormous number of possible combinations or programs until one happens to work for that specific puzzle.
And this explains the eye-popping result from OpenAI's O3 model on ARC.
That's the argument. O3 got a very impressive score, 87.5% on a semi-private test set.
Mm.
But how did it get it? Not usually by figuring out the core abstraction like a human might, getting it right on the first or second try. No, it got it through massive trialing.
Just trying millions of things.
Essentially, yes. Searching vast numbers of potential program paths and the estimated cost. For the high compute version that got the top score, it was around $3,460 in compute per task.
$3,500 to solve one of these little grid puzzles.
Approximately, yes.
Yeah.
That cost completely reframes what success means here. If it takes that much compute, are you measuring intelligence-efficient problem solving, or are you measuring the ability to throw enormous resources at searching a predefined space? It looks much more like skill optimization powered by computation than genuine efficient reasoning.
And that approach just doesn't work for most real-world problems.
Absolutely not. You can't spend thousands of dollars exploring every possible outcome when you need to, say, make a split-second decision in a self-driving car, or diagnose a patient in an emergency room, or interact dynamically in a human conversation. The real world demands reliable generalization, finding the right answer efficiently, often on the first try, based on abstract understanding. This massive trial and error approach fails that test.
Okay, so if benchmarks like ARC are getting gamed or saturated by computational power rather than intelligence, what does a better benchmark look like? What would a true universal test for general intelligence need to have?
The sources point towards benchmarks that force genuine abstraction and adaptation under true novelty. First, they need to use randomly generated worlds.
Randomly generated, meaning the AI can't have seen the rules of this world in its training data.
Precisely. Imagine high-fidelity simulations of environments that are fundamentally non-human, maybe even non-intuitive. A simulated gas planet where gravity is tied to color. A digital game where causality works backwards sometimes. The rules are arbitrary and unknown to the AI beforehand. So the first challenge is just figuring out the physics of this new place.
Exactly.
The AI has to spend its intelligence budget efficiently, just learning the regularities of this alien environment before it can even start trying to achieve goals within it.
And how would you measure success then? It's not just about solving the puzzle.
No. Success would be rated on the efficiency and the breadth of goal achievement across these diverse, unknown worlds. The focus has to be entirely on rewarding the algorithm's ability to identify hidden patterns, understand causality, and adapt its intelligence rather than rewarding its ability to recall pre-programmed skills or search exhaustively. It forces abstraction over computation.
This has been fascinating, digging into the definition and measurement of capability. But capability, AGI level, that's only one side of the coin, isn't it? The other side is how we actually choose to use that capability, which brings us to autonomy.
Absolutely. This is a critical distinction we have to keep making. Higher AGI capabilities, they unlock potential new ways for humans and AI to interact. But, and this is the key point, the level of autonomy given to a system is, or at least should be, a deliberate choice.
It's not automatic. Just because a system could operate fully autonomously doesn't mean we have to let it.
Exactly. It's a design choice made by developers, by deployers, by end users, based on safety considerations, the context of the task, ethical boundaries. Autonomy isn't an inevitable consequence of capability. It's a parameter we set.
And getting that parameter right is crucial for managing risk. The sources propose a framework for this too, right? 6 levels of autonomy in human-AI interaction.
Yes, it provides a useful spectrum to think about safety and control. Level 1 is the most basic, AI as a tool.
Like using spell check.
Perfect example. The human is fully in control, making all the substantive decisions. The AI just automates small, mundane subtasks. This level is unlocked even by relatively simple, narrow AI, but widely used with competent narrow AI. Risk here is pretty low, maybe minor errors or just productivity impacts.
Okay, level 2.
Level 2 is AI as a consultant. Here, the AI plays a more significant role. It might generate ideas, draft content, analyze data, but crucially, it's only invoked by the human, and the human reviews and approves the output.
Like asking an LLM to summarize a long report or help write code.
Exactly. This level is typically unlocked by expert narrow AI, or maybe today's emerging AGI. The risks start creeping up here, things like over-reliance on the AI, missing subtle errors it makes, or even enabling more sophisticated misuse like targeted phishing scams crafted by the AI consultant.
Okay, level 3 takes it up a notch.
Level 3 is AI as a collaborator. This implies a more co-equal partnership. Human and AI work together interactively on a complex task, both contributing significantly. Think about a grandmaster analyzing chess positions with an advanced chess engine they're learning from each other.
Interesting. What unlocks this?
This likely requires at least emerging AGI, maybe leaning towards competent AGI for really seamless collaboration. And the risks here become more societal. Things like people anthropomorphizing the AI, forming emotional attachments, placing too much trust in it. Also, the sheer power of optimized human-machine teams could accelerate societal changes in unpredictable ways.
Right. Level 4 is where the balance of power really shifts.
Yes, level 4 is AI as an expert. In this mode, the AI takes the lead. It drives the interaction, makes most of the key decisions, or performs the core task. The human role shifts to providing high-level guidance, setting goals, maybe giving feedback or validation.
Like the AlphaFold example. Scientists using it to suggest protein structures they then test.
Precisely. The AI proposes, the human disposes, or steers. This level requires very high capability, usually exceptional narrow AI like AlphaFold or potentially expert AGI. And the risks here become quite severe, moving firmly into those structural risks we discussed. Mass displacement of human experts, challenges to human exceptionalism, maybe even societal stagnation if we rely too heavily on AI insights.
And finally, the highest level, level 5.
Level 5 is AI as an agent. This is fully autonomous operation. The AI can understand complex long-term goals and execute them over extended periods with minimal or perhaps no direct human supervision.
This is the sci-fi vision of AI agents running businesses or scientific research largely on their own.
That's the idea. We haven't really unlocked this in a general context yet. It would almost certainly require exceptional AGI, maybe even full ASI capability.
And the risks.
Maximum risk. This is where catastrophic misalignment becomes a major concern. An agent pursuing a poorly defined goal with immense power and unforeseen consequences. Also, the extreme concentration of power if only a few entities control these hyper-capable agents. But, and this is the vital safety check, even if we develop level 5 capable AGI.
We don't always have to deploy it at level 5 autonomy.
Exactly. Lower levels of autonomy must remain available, even essential. Think about self-driving cars again. Even if we have perfect level 5 autonomy, you still need level 0 manual control for situations the AI wasn't trained for, like extreme weather, or for training new human drivers, or for regulatory testing.
The off switch is still crucial.
Absolutely. The same applies to AGI. Even with ASI, we'll need scenarios where we mandate lower autonomy levels, level 1 tool use, level 2 consultation for safety, for education, for auditing, for situations that demand human judgment or intervention.
And for any of those higher autonomy levels, 4 or 5, to be even remotely safe, it seems like we loop right back to that need for metacognition.
Indispensable. An autonomous AI agent operating at level 4 or 5 without strong metacognitive skills is inherently reckless. It must know its own limitations.
That model calibration again.
Yes, reliable model calibration, the system accurately reporting its confidence level. I'm 99% sure about this diagnosis, but only 30% sure about the treatment plan. Consult a human specialist. And maybe even a robust theory of mind, understanding the knowledge, beliefs, and intentions of its human collaborators. Autonomy without self-awareness is a recipe for disaster. Hashtag tag outro.
Well, we have certainly covered a huge amount of critical ground here, really trying to operationalize this path to AGI. We started by moving it from philosophy to governance, establishing that crucial difference between generality, the breadth of tasks, and performance, the skill depth relative to us humans.
Yeah, and we saw how that two-dimensional framework is actually being put into practice through things like Anthropic's responsible scaling policy, RSP, and those graduated AI safety levels, ASLs. It's fascinating to see specific triggers like potential CBRN misuse being used to mandate immediate, tough safeguards, all backed by auditable frameworks like NIST and ISO.
And we really dug into that measurement problem, making that vital distinction between just showcasing sophisticated skills, often through massive computation, and measuring genuine intelligence, that ability to adapt efficiently to truly unknown environments, rewarding abstraction, not just brute force.
Definitely. And finally, we tied capability back to deployment, emphasizing that AGI capabilities only unlock autonomy. The actual level of autonomy we grant these systems is a critical design choice, a safety control, that has to be managed carefully across that 6-level spectrum to mitigate potentially catastrophic outcomes.
So the synthesis seems to be this complex interplay between the AGI level matrix and the autonomy level choice. But that brings us back to the speed and the unevenness of it all.
That's the pressing challenge, isn't it? We laid out how AGI progress might be nonlinear.
Yeah.
A system could hit level 3, expert, in some really sensitive area. Maybe material science, maybe financial modeling, maybe cyber defense before it achieves solid level 2, competent ethical reasoning, or self-awareness.
So the capability might outpace the wisdom or the safeguards.
Exactly. And if managing the risk means constantly adjusting safety policies and autonomy levels based on these rapidly, unevenly advancing capabilities, are we basically always going to be one step behind? Is effective governance structurally possible when the thing you're trying to govern is moving exponentially faster than the governance mechanisms?
Which leaves us with a final, maybe unsettling thought for you, our listeners. If the very systems holding the most promise, say expert AGI revolutionizing science or medicine, might arrive with potentially dangerous expert level knowledge, but maybe only competent level, or worse, emerging level self understanding, can we ever truly get ahead of the risk? Or are we destined to be perpetually reacting to capabilities that have already leapfrogged our ability to safely manage them, especially as we approach superhuman levels in areas we can't even comprehend?